Hello, and welcome back to the second part of the SmartyKit build update. As you can see, I've done a bit more than in the first update, as you would expect. I think in the first update, I'd done the video display side of things, and I'd done, I think, most of the keyboard. So this top bit over here really is like a dumb terminal in a sense. It's got an Atmel processor controlling screen and another Atmel processor controlling a PS2 keyboard. Now, I did go and buy a new PS2 keyboard, a slightly smaller one for the office, because my other PS2 keyboard is a full-size keyboard, which was getting a bit cumbersome for here. So I've continued further on, and I've done a bit more of the 6502 processor side of things. That's the 6502 there. I've got the 1 meg oscillator over there, and the boards for the memory and the ROM are in. There's a NAND gate in there, a memory decoder in there. And I was starting on the ports decoder. Again, as mentioned in the first one, I'm cutting all the jumpers to size just to make things a whole lot neater. And I've started to move some of the power linking jumpers from the side of the board to that side of the board and just neatening those up as I go along. The other thing I did was to take the battery pack off with a couple of AAA batteries in there that's really not lasting very long. It's fine while you're doing a build, but if you're messing around with it for any length of time, then the batteries run flat pretty quickly. So I've added a breadboard power supply on, and that does the job. So if I switch this on, the dumb terminal boots up, and you can see it busy going over there, and it will display the ASCII art. The keyboard driver, or the keyboard interpreter, has this signal coming out. Now, I don't know if that's the clock going directly into the keyboard or whether it's just another signal. I mean, the clock signal over here is coming out on D4 over here. So I don't know. Oh, actually, that's an address line coming out there. But anyway, there's a signal coming out there. I'm not quite sure what that's for yet, although I do use it a bit later, as you'll see. From the keyboard, if you look at the screen, you can see the keyboard's working. You'll see a bit of text coming up here as I type. And of course, it's not doing anything at the moment because it's just acting as a dumb terminal. So it shows, however, that the keyboard works. And I do like that about the way this has been put together, is that it gives you some quick, easy wins. This is a pretty easy bit of circuit to put together, both of these, and it gives you something pretty impressive to look at. And you don't end up spending hours putting stuff together and then not knowing whether it's going to work or not. So I'm pretty happy with the way it does that. When you get to this part, the milestone, so the interactive side of things, the interactive website, will come up with a little video after each one of these that shows you what's going on. And the one that comes up for having put the processor down shows a bit of video with 3 LEDs coming off the address lines. So actually, they've got them on address lines 13, 14, and 15. And that doesn't look very impressive. It doesn't look like much is happening there. And the reason is you're running at a megahertz here. And so it's cycling through those address lines pretty quickly. So here is the bit of video that they show. It's just a very short clip. And you can see it. Let's go again. Let's take the sound right down. You can see it busy flashing over there, the address lines going, and that is on the last 3 address lines there. But if we switch back to the desk view, you'll see that is just not happening. And you might think that it doesn't work, that something's gone wrong. But it's the 1 megahertz crystal is just way too fast to be able to see that. And so you have to slow it down. And I don't know whether they slowed the video down for this. But if you just take this signal over here, which is a nice slow clock, and let's just switch this off at the moment, take the clock line out, which is the output of the crystal, into the input crystal of the CPU. And we just put that in there. and switch it on, you'll see a bit more activity there. One LED is switched off properly and the other two are on. And obviously the top address lines are moving a lot slower because the binary lowest least significant bit is happening from here. So you can see a bit more activity there. And if we move this back down to the bottom three address lines, then you get a far better idea that the process is working. And this is a pretty good thing to do because you want to see that the various control lines have been pulled high that allows it to do something, that allows it to start, and that the crystal is, well, in this case, not the crystal, but that a signal is driving this. It's just the 1 megahertz is too fast. You're not going to see it. So that's a bit of an odd thing about this. But the other thing that worries me slightly is that there are no current resistors, current limiters on these LEDs. Now, it appears that the address lines are only syncing 20 milliamps, which is fine, and the 20 milliamps is fine to drive these LEDs without blowing. But it's a bit of a risky thing not to talk about that in the design and as you're going through this, because if these were able to sync 50 or 60 milliamps, you would burn out your LEDs, or more likely you would burn out the chip itself because it simply can't sync that much. So they really should have at least something, even a 50 ohm limiting resistor on here. I think the other thing they probably should talk about, and I'd have to check the specs, and maybe you can do this, but if you put LEDs on all 15 lines, you're going to be sinking a lot of current through here, which again, it probably, I don't know whether it can deal with it or not. I'd have to look at the data sheet to see. So I think I would have spoken about that a bit. The other thing that I noticed with this is that they have a bridging board which bridges the address and data bus between the CPU and the memory, which is quite a nice idea. I mean, it does save you from having to wire up all of these address and data lines. But I was lucky because I actually had this one row down, and this didn't fit in, and I was a bit worried about whether the continuity would work across here, and so I thought I would try it out. And I discovered, if I bring my multimeter up, put this onto continuity. Here we go. If we start running through these, we've got nice continuity all the way through, except when we get to D0, nothing there. D1, D2, D3, D4, D5, D6, D7, open circuit. So this board has actually got two open circuits here, which I'm really glad that I discovered now, because that would have been quite a thing to work out what was going wrong later on down the line when you're trying to do self-test, because obviously the software simply wouldn't run. And I suspect it's probably just dry joints and something here. So I will solder this up, or I'll resolder these points here and see whether that works. And if that doesn't work, I'll just solder some jumpers across here. But I wonder if anybody else has had that issue. Anyway, I do quite like the idea. It does save me a bit of time. And that will go, as I say, we'll go across there and bridge those two. So that's where we are at the moment on the build. I think there's a bit more I need to do up here in the ports decoder. I need to work out when I can do the main self-test side of things. And that'll come up in the next section anyway. The interactive assembly site is, I think, quite a good idea. There's a few things that I think need a bit of work on. The first thing, if I refresh the site, so every time you come into it, it doesn't remember where you are, or where you were at least. It always resets you back to step 0, which is a bit of a pain because you've got to try and find your place. And you've either got to click next to get there, or you can use the slider. If you've remembered what step number you're on, then you can get to it, but it's a bit fiddly. It would be nice just to be able to step in here, or as I say, even better, it just remembers where you were since you last finished. So that's one thing. The other thing that I would have liked in here is that if you're working down here, especially if you're on a bigger screen, or if like me, I was zooming so that I could see what was going on in the screen better. But that means you've got to keep coming back up here to click back or next. And what happens is you click next, which one, you've got to try and remember what wasn't there in order to see what was here or what is here now. It would be better, I think, to have maybe use the cursor keys for left and right, or to have these next buttons moving over here, so that if you're working on this section, the back and next buttons are over here and always visible. You can see what's going on. The other thing I think would be very useful is if you clicked on one of these, it just highlighted. So if you're going a bit further down the line, and you take these ones, for instance, if you're trying to work out where these are going, it would be useful if when you clicked on it, it highlighted or became more bold or something, just to make it a little bit easier to follow where things are going. For a simple step-by-step, put this wire here, and then put this wire, then put the next wire here, I think this is a great way of doing it. I think what's missing out of this is the step-by-step information about what you're doing. It does give you a little pop-up after each section. If I can find it again, this is a slightly annoying thing because I'm going to have to click through. But if I get to the end of the terminal, there's a milestone that comes up. These images are not working at the moment, I have told them, and they say they will sort it out. So I'm sure hopefully by the time you see this, these images are working. And there's a bit of video down here on the testing side of it. And it gives you tests that you can do, testing the keyboard with LEDs. But what it doesn't do is tell you, so it's telling you to test the keyboard with LEDs, but it doesn't tell you where to put those LEDs. And you can work it out from this little video that comes up. I've just got the sound off at the moment. But it takes you through this and shows you what should be happening, but it doesn't take you through setting up that test. So I think that's something that could be improved on as well. Perhaps what we need here is some more links on the page so that I can click on different items in order to get more explanation about what's going on here and why is it wired up this way. What's happening? So the other issue that I had with this, which I think could again do with a little bit of work, if I click into this section, you'll see that there are 3 wires that have come up. Particularly these 2 wires over here. Let me just zoom in a bit on the screen. It's placing the wires in before the modules are there, which would be fine if your breadboards are laid out the same way as they are here, which mine are not. So if I switch over to the breadboard, you'll see on here that the positive is at the top and then the negative is there, and the numbers, if you can read it, I think is not quite in focus. But the numbers go from 1 on this side to 60 on this side. Whereas if we go back to here, you'll notice where it's the other way around. Our negative is at the top and our positive is at the bottom of each breadboard. And we're numbered from 1 to 60 this way. So that's the other way around. And obviously there's been a change in the breadboards that they're using, and that's, I'm okay with that. That's fine. But there should be an option in here where you can choose which breadboard you've got, so that you can line things up. So it becomes difficult to lay this down because if I'm going from 1 to 60 this way, obviously this is not 11 and this is not 18. It's something else, which just makes it a little bit more fiddly to work out where those are going. It would have been better, I think, to put the module down first. I don't know why. It's maybe just a sequencing thing. I don't know what's behind this. But if the module was down first, then it would make it easier because you could follow the letters and the numbers that are on the modules itself. But again, I mean, not a big issue, but just something that would help. So part of the online instructions is to send them an email to register the kit, which I did. and I was told that I would get a login and invite to a Norton online system, which had more information. And that didn't come for a couple of days. And after a prompt, they sent me a direct link. So that seemed to work. And if you go into that, this is the link that you get. And this has got a lot more information in it. It goes through what's in the box, what to assemble, how to assemble, the steps, assembly steps, testing, software, drivers, starting, and technical reference. So this I thought would give me a lot more information. However, I still think it's lacking in a fair amount of information. It seems a bit disjointed. Technical resources, link to data sheets and useful integrated circuits. It's incomplete. Clicking this link will take you back into the Norton system, and it gives you a couple of commands to run. And these are these are little programs that are obviously on the ROM at the moment. So you've got a part that you can print out, the WAS face that you can print out, and then it goes into modifying drivers, and it takes you onto GitHub where you got the code and you can modify the drivers for the Atmel, 3 Atmel processors. Yeah, the video driver, the LCD driver, and the keyboard driver, which I'll probably have a look at some point. So not much over there either. So it shows here it gives the listing for the keyboard driver and the video driver, which is quite useful for debugging. You'll see in my next video when I was debugging a problem, there's this keyboard code gave me a clue as to what was going on. But there's a lot of code over here, and this should all just be in the GitHub. It's a waste of the page here. If I go back up to the top and say assembly instructions, this again seems incomplete because it gives you an idea about putting the breadboards together. That's good. It gives you an overview of the modules and the chips that are in there, how to put a chip in, and how to put the stickers on, how to put the screen together, where all the different modules go on the boards. It gives you the controller layout, so you can see how that works. That might be the part of the first test. And if you look at some of the testing videos that are around, it really does talk about being able to test the keyboard out in a different way. Then it shows you the screen as you would see it. Numbers of wires, board again, and then it goes into testing. So it talks about assembly. We go back to the top. How to assemble steps. But actually all the steps are not there. And there could be so much more in this section about what you're doing in each section, how the system works, what each part is doing, and get really into explaining how this whole computer works, which I think is completely missing here. There is a video which does go into a fair amount of explanation. Yeah, this one, how Apple One works. So this, you get taken through a block diagram of the Apple One and how the different parts relate to each other. And that's good. Definitely watch this. It'll take you through a fair amount of information. But I do think that as you're assembling, you want to go through the CPU board and what's happening on the CPU board and the memory board, and how do all these bits work as you're assembling it, so you can learn about the computer and the Apple One's operation, electronics, and software as you go along. And I think that's really missing from here. As I say, there is a lot of good information in here. There's memory maps and layouts of the boards. This is the one where the blue rail is at the top, or underneath is the negative and the positive rail, and the one underneath it, the negative and positive rail, are the other way around. But again, as part of the assembly instructions, that really should have been spelled out right in the beginning. So I still think there's a lot of work to do here, and I think it'll get there. It just needs more attention on this, and it needs some structure, and it needs some better steps. And I'm sure it'll get there. So that's it for the second update. I have a third one coming out where I'm hoping you'll see the whole machine up and running and working. So until then, enjoy. I'll see you then. Bye-bye.